Okay, I'd like to talk to you today a little bit about slope. And in algebra, when we talk about slope, we're talking about a rate of change between 2 points. And if I pick these 2 points, I'll go with this one, which has coordinates. The x-coordinate is a -2. The y-coordinate is a 4. -2 for x because we go to the left. A +4 for y because we're going up. The other, let's say I pick another point over here, and so the coordinates for that point, since I'm going to the right, would be a +3. Of course, I'm starting from the origin whenever I do this, and I'm going up, so that's a +1 for the y-coordinate. Now, slope is very often referred to as the change in y with respect to change in x. And this is where we get into this idea of rate of change. So if I start at this point here and I want to go to the other point, well, if I'm going to change my y, I'm going to have to go down 3 units, and my change in x will be to the right 5 units. My change in y is often denoted using a Greek letter delta as delta y, and my change in x would then be a delta x. And since we all know that down on the coordinate plane would mean negative values of y, so this would be a change in y of -3, and to the right in our x-coordinate would mean a +5, because we can count them right off. 1, 2, 3, 4, 5. So my change in y would be -3. My change in x would be a +5. And slope is defined as the ratio of the change in y with respect to the change in x. So in this case, we would have a -3 for our change in y and a +5 for my change in x, thus giving me a -3/5 as a value of slope. There is also a well-known formula for slope. If all you had were the coordinates, you didn't want to draw a picture, count out everything, and that basic formula is denoted as a change in y being y2 minus y1 divided by a change in x, which we would find by taking x2 minus x1. Now, what's with all these subscript notations, etc.? Well, the way that we would use this is that we would simply assign our 2 points a number. And if I call this point 1 and the point over here point 2, then that would mean that y2 would be the y-coordinate of the second point, or the point labeled 2, and in this case it's a 1. Now when I do this, to avoid problems with signs, I start by simply putting in parentheses. And you may find this to be really helpful as time goes on. So y2 in this case would be the y-coordinate of the second point, that's a 1. And x2 would be the x-coordinate of the second point, and that's a 3. Likewise, y1 would be a 4, and x1 would be a -2. Now, I want to make a point of the fact that it's really critical that these coordinates stay together for any given point, that you don't split them up and move them around or anything like that. So it's always 2 minus 1, and then how you label your points will determine what numbers go in there. And in this case, if I go ahead and just sort of simplify the arithmetic, 1 minus 4, well, that will give me a -3. 3 minus a -2. See what I meant about the issues around signs? We have to be very careful. That would then result in a 3 plus a 2, or a 5, giving us that same slope of -3/5 that we got by simply counting. Now, for any given 2 points, the slope should always be the same, no matter how you calculate it. So you might ask, well, what if we labeled those points differently? And I'll run through a very quick example here. We'll just flip them around so that we call the point -2, 4, point 2, and we call the point 3, 1, we call that point 1. And let's go ahead and calculate slope again using that notation. Well, the slope in this case, okay. Well, we'll put in my little sets of parens, and we first look for y sub 2. Well, in this case, y sub 2 would be a 4. X sub 2 would be a -2. And y sub 1 would be this 1 here, and x sub 1 would be a 3. Well, let's now do our arithmetic. 4 minus 1 gives us a 3. And a -2 minus 3, oh, that's a -5. And sure enough, my slope is still a -3/5, even though I changed the order in which I numbered the points. This can also be seen on the diagram, where if I start at point 1 and I want to get to point 2 in this case, well, if I'm going to do my y change first, I go up 3 units and to the left 5 units. So that means if I'm going to the left 5 units, that would be a -5 for a change in x. And if I'm going up 3 units in the y direction, then that would be a change of +3. And then my ratio, again, 3 to excuse me. Just like that, I get a -3/5 for a slope. So summing up, what I want you to take away from this is the fact that the slope between 2 points can very easily be calculated using the formula y2 minus y1 over x2 minus x1. And as I showed you in the previous example, you take 2 points. It doesn't matter which one you label as point 1 and point 2, you will always arrive at the same value of slope.